Hello everyone, Mrs. Belo here. In this video I'm going to be going over the Chapter 12 notes in the Chapter 12 and 13 tab in your OneNote, slides 14 to 18, which is calculating molarity. So molarity, which you did for homework, the PhET, it is solving the concentration of a solution. So in chemistry, to measure concentration, something that we're going to use is called molarity, which is, we use big M to represent that because that's important because the little m is going to represent something different, which is molality, which you're going to learn about tomorrow. To calculate molarity, there's two ways to look at it. I have the formula and then I have this triangle. This triangle is similar to the density triangle if you remember using that last semester. And to find molarity, you have to do the amount of moles of the solute, which is whatever substance is being dissolved, divided by the liters of the solution. And most likely the liters of the solution, that's going to be how much water you have, because the water 99% of the time will be your solute, which is what the solvent, which is what the solute is dissolved in. So it's moles divided by liters. If you're looking at the density triangle here, this is one way to look at it. So if you're solving for molarity, well, the only two variables you have left in the triangle then are moles divided by liters. Versus if you were trying to solve, let's say, for moles, that would be then the two variables that you have left, which is molarity times liters. And if you are solving for liters, that would be these two variables that you have left, which is moles divided by molarity. So the triangle here is just a shortcut for finding whatever it is you need to find, whether that's molarity, number of moles, or liters. So I'm going to go ahead and do 4 different example problems for you. So first question here, what is the molarity? So that's the big M that we're going to be solving for. And remember, molarity is moles divided by liters. And again, you can use the triangle here. If you're solving for molarity, then it's going to be moles divided by liters. And they tell us we have 0.5 moles and 10 liters of a solution of NaCl. Of a solution of NaCl. So pretty straightforward. Molarity is moles divided by liters, so we're going to do 0.5 moles divided by 10 liters. So 0.5 divided by 10 is going to give you 0.05. Now the units for molarity is technically moles over liters because it's a derived unit because you have moles over liters. But since another way to represent this more easily is just write big M for molarity. Big M for molarity, that can be your unit. Okay? So that's a pretty straightforward problem. Molarity is moles divided by liters. So let's do another problem where in this situation we're not going to be given moles but grams instead. So it says what is the molarity? So we're still solving for molarity, which is big M, which is moles divided by liters. And it tells us we have 3.5 liters of our solution. So that's the L, that's the liters. So we know what that is. So I'm going to go ahead and put that in the bottom. But then it tells me I have 62.5 grams of KCl, which is potassium chloride. That's not in moles, and we need moles. Well, to get grams into moles, we have to do a picket fence, and we're going to have to calculate the molar mass using our periodic table. Just going to pull up the dynamic periodic table. Let's see, periodic table. Just so I can show you how to get that molarity if you don't, the molar mass if you don't remember how to do that. So we have KCl, so we have potassium, which is, and we have one potassium, which is 39.098. So I'm going to just show my work off to the side here, 39.098. Plus we have, so that's the K, and then we have Cl, which is chlorine, and chlorine is 35.45. Plus 35.45. And if you're ever doing your homework and you're not sure what the molar mass of something is, or if you calculated it correctly, you can look it up on the internet. So I got 74.548, and remember this is molar mass, which is grams per mole. So in order to get grams into moles, I'm going to put the molar mass in the bottom, the 74.548 grams, and then on top, 1 mole. So then I'm going to do 62.5 divided by 74.548, and I'm going to get 0.8, and I'm just going to round 2 decimal places, 84 moles. So now I can plug that in for moles into my equation. So 0.84 moles. And now I can divide that by the 3.5 liters to get my molarity, which is 0.24. And then again, just write a big capital M, big M, for molarity. So you're always going to be using the equation or the triangle for molarity in some way, but sometimes you just might have to convert some units before plugging into the equation. Now let's say that we have a problem where we're not solving for molarity this time, but let's say we're solving for moles. So this time we're going to solve for moles. And again, this is a way to use the triangle, so you can easily figure out how to use the equation to find moles. So moles then would be molarity times liters, okay? You can imagine that there's a multiplication symbol here and there's a division symbol here. So we're going to do the molarity times liters. So our moles are going to be molarity, which in the problem they state is 3, times, now notice that the solution, the amount is in milliliters. So I have 250 milliliters, but I need that in liters. So I have to convert milliliters into liters. So you could do one of two things. You can do a picket fence or divide by 1,000, or you can simply just move the decimal over 1, 2, 3 spaces. So 250 milliliters is 0.25 liters. So now we just have to multiply 0.25 times 3 to give us 0.75, and remember this time we were solving for moles, so moles would be my final answer. For our last example problem, this question is asking for the mass of potassium hydroxide, which is KOH, in order to prepare a 1.5 liter solution that has a molarity of 9.5. So we have liters and we have molarity. So you're actually going to be solving for moles. And then once you have your answer for moles, well, you can easily convert that into mass or into grams by using your periodic table to find molar mass. So I'm going to be solving for moles. So you can equivalate moles when you're using molarity with grams, because we can convert between grams and moles by doing a picket fence and finding molar mass. So I'm going to find moles first, which again is going to be molarity times liters. So I have my molarity, which is 9.5. And they gave me the amount of solution already in liters, so I don't have to convert that. So I'm going to find my moles. So 9.5 times 1.5. So I have 14.25. Now, right now my answer is in moles, but I need to get my final answer into grams. So in order to get moles into grams, I'm going to have to find the molar mass of KOH, which is potassium hydroxide. So I have potassium, which is 39.098, 39.098, plus oxygen. I'm just going to round that up to 16, plus hydrogen is 1.008. 1.008. Oops, oh no. Get my OneNote back here. Okay, so I'm going to calculate the molarity by adding those together. And again, if you're not sure while you're doing your homework, you can look up you can Google the molar mass of a substance just to be sure that you calculated it correctly. So I got 56.106 grams per mole. So when I'm plugging into my picket fence, remember if there's moles here, I have to have moles in the bottom. So that's 1 mole, which is equal to the molar mass of KOH, 76.106 grams. So now I have to multiply 14.25 times the 56.106 to get my final answer, which is 70.3. I'm going to round 2 decimal places. Grams is my final answer. The only type of problem that I didn't include here as an example was a situation where you would calculate liters. So if you have to find like liters, that would be moles divided by molarity. And if you had to find milliliters, then you would find liters first and then convert your answer into milliliters, similar to what we did here in this last problem. Your homework will be the molarity and molality worksheets. We're going to do molality, tomorrow. So molarity is just the first 3 problems here.